welcome back. My name is Sarah Fuentes and I'm here to do more math lessons with you. Thank you to everyone who responded with questions. There was a lot of excitement this morning and engagement, and I have 4 new topics to cover for this afternoon. So let's get started for today. Oh, wait, quick reminder. If you have more questions, feel free to just drop a picture, drop a question in the comments box, and I'll try and respond on my computer. If I have some more time later on, I can take at least 2 questions live. Anything else I might try and just fit into a later video. Okay, so we're going to get started with the first one, which was sent to me through Instagram actually, and it is on fractions with adding and subtracting. And this person asked, does this algorithm work? They had this addition problem and they saw someone solve it using something called a Butterflied Method, and it has to do with multiplication. So in a TikTok video, they saw someone draw true circles this way, and they were multiplying these 2 numbers, 4 times 2 making 8, 5 times 3 making 15, and then they multiplied these 2 numbers to get 20, and so they just added 15 plus 8 to get 23. And the person asked, is this fake or is this magic? Does this even exist? Are you allowed to even multiply in this way or add and subtract in this way with fractions? And why does it even work? And so I went on Instagram and looked at the problem, and I was like, yes, this actually does work. This comes up in around 6th grade math, and it's just showing the same mathematics, just in a very different way. So let's start with the bottom with our denominators with 4 and 5. I know that we can't add these 2 fractions together because they have different denominators. 4 and 5, they're different sizes. So when we multiply them together, we're coming up with a common denominator. Not always the least common, but it is a common one because 20 becomes something that I can multiply for 4 and 5. Okay, so that's what's getting there. I'll show you the traditional way too at the same time so you can kind of see it. And that's when people go and figure out what's the common denominator. 20. And they know that 5 times 4 makes 20, and they know 4 times 5 makes 20. So how do you come up with your top numbers, pretty much? Okay, so then they do this other method where they're multiplying 5 times 3 to get 15. Well, why are you multiplying by 5? Think about it down here. So my common factor here, I'm multiplying by 5 to get 20. So I'm going to do the same with my numerator. 3 times 5 to get 15. And these 2 fractions are equivalent to each other. So that's why that works. Same thing happens here. Why am I multiplying 4 times 2? Well, because I already have my common denominator, 5 times 4 to get 20. And I'm going to do the same thing up here. I'm going to multiply my numerator times 4, 2 times 4, to get 8. So you are still getting these same fractions, 15 over 20 and 8 over 20. And you can add them up together to get 23 over 20. Yes, I know I'm not all done because it is improper, so you're going to have to do some division. This is a division line. 23 divided by 20 gives me 1 and 3/20. So this method absolutely does work. Kids really like it because it's quick and it means I don't have to do the separate work in it. However, it seems tricky for some people. It seems like magic because the math is hidden. I'll just do one more just to make sure you have the steps for this. Let's say you're doing, I'm just making up numbers, 2, 6, this time I'm going to do minus 1/8, okay? And we're going to do the same thing. It's kind of like going, you're going to multiply this way, and then we're going to, here, multiply straight. So 1 times 6 is 6. 2 times 8 is 16. Only this time, I'm subtracting because I have a subtraction problem. And my denominator 6 times 8 is just 48. Okay, so I have 16 minus 10 over 48, or 6 over 48. And I'll just simplify that. But you can definitely see how much faster it is to do the subtraction because I'm doing this butterfly method where we're just multiplying this way and then the bottom's just this way. And once I have this to this point, you can do some simplifying. And I can divide both of these by 6 to get 1/8. So for my viewer on Instagram who suggested this question, no, it is not magic. It actually works well, and thank you so much for bringing this up. I think so many kids are going to love this method. It's so much faster for adding and subtracting with fractions. Okay, so let's look at our second fraction problem. And this comes from Connecticut, from Ari Graham. Little Ari. And I knew her mom. Her mom is an awesome literacy teacher, and she sent me this problem. I'm just going to look at it on my, actually look at it on my phone so we can see it. Let's see. Use a picture to find a fraction equivalent to 1/2. And the picture she has is a rectangular prism, rectangle, nice little array. And we have this shaded in to show 1/2. And equivalent fractions can be very, very tricky for a lot of kids, especially when they're starting with the concept, because it means I still have half of something. Even if I break it up into more pieces, I always have half. So try and think if I had a cookie and there's one cookie and I broke it in half. Or if I had a cookie and I broke it up into 4 pieces, how many pieces still make up that half? And so this becomes a little tricky for little kids to understand because it's the same whole. I'm just breaking it up into more pieces. So what I recommend for a lot of families is to do some skip counting. And you can make tons of equivalent fractions this way. So one easy way is I can start skip counting on the top. 2, 3, 4. So 1 times 2, 1 times 3, 1 times 4, and I can do the same thing on the bottom. 2 times 2, 4. So I'm just skip counting by 2's. 2, 4, 6, 8, 10. And you have all of these can represent equivalent fractions. And you can do the same thing with, I'll do a different number. Let's say I have 4/5. I can do the same skip counting. So count by 4's, 4, 8, 12, 16, 20, and I can count down the bottom, 5, 10, 15, 20, and 25, and these are all equivalent fractions. So 8/10 has the same value as 4/5, has the same value as 12/15, and so on, and so on. And if you're really wondering why, when your kids get a little older and they start thinking about multiplication, they can see why this works. Or I can take 4/5 and 12/15, and your kids can start looking for patterns, and patterns are great with fractions. They might start noticing that there is a multiplication pattern happening here, where I can see how do I go from 5 to 15. I can multiply by 3. And so some of my kids used to imagine like a little magic box here. And they used to go, oh, I can just multiply by 3. 5 times 3 makes 15. 4 times 3 makes 12. But I want to make sure I'm giving you good math. So I'm really multiplying both the top and the bottom by 3. So just notice that 5 times 3 makes 15. 4 times 15. 4 times 3 makes 12. And the other thing you'll probably notice is, look at this value here, and they learn this when they're older, this still has a value of 1. And that's why the value isn't changing. I'm still multiplying by 1 and to get another number. And it can also work the other way if you're thinking division. Let's say I have a bigger number, let's say 8/12, and I have 2/3. How can I get from here to here? I can still think of my factors here. How do I go from this way to this way? I can think of it times 4. And this number, 2 times what? 2 times 4. So it's a multiplicative rule that's happening here. I'm still multiplying by 1, but I'm multiplying by 4/4 as in terms of 1. And it still works. So these are equivalent fractions. I hope that really works. Okay, so Ari, I hope this really works for you in terms of how do you make more fractions? I can just do this. And even if I have more boxes here, if you're still looking for half of it, you can think about what the original piece is and just cutting it directly in half. Okay, so hope that one helps. If you have additional questions, please ask, but thank you for this one, for sharing. I think Ari's in 2nd or 3rd grade right now. Okay, so let's clean this up a second. And we're going to get to our 3rd problem, which is a 6th grade geometry problem having to do with area. And this was from Engage, New York. And the question went, you have an obtuse triangle. Let's see, 9 here, 7, and then on the outside there were some dotted lines, 3 and 8, and they were asking what is the area of this figure right here. And we have our trusty formula, area equals base times height divided by 2. Tricky part with this is you have a triangle with tons of different numbers, and for kids a success point will be you have to be able to identify which is the base and which is the height. Now in this case, the base is what will go flat on the bottom. If I put this on a table, this would balance it nicely. So here is my base. And now I need my height. So going from that bottom floor, going straight up to the top. And this is where it can get confusing. A lot of times kids just use this other side as a height, and sometimes that's true. But in this case, it's not. It's just a side length. It's not telling me how high it is from this point here going straight up. And I want to be able to make this 90-degree angle from the bottom, from where the base is, to the top. I can't do that in this way because this isn't a 90-degree angle. So I'm going to use this number here. This is actually my altitude, but I can still call it my height. When you get to high school, they'll use altitude instead. And now I can add in those numbers and substitute. So my base is 9 times my height 8, and I'm going to divide by 2. I'm going to use my order of operations and do this part first on top before I get to the bottom part. And 9 times 8 is 72 divided by 2, and 72 halves is 36. So my area is equal to 36 square units. Okay, so that's how this can get a little bit tricky. What do you do when you don't have an actual height? So in the obtuse triangle, you have to use the altitude. You are not using this. This number is not necessary at all. Neither is this one in this case. Now, to be fair, there is another way of doing this that I've seen. And you might have this if you're doing Common Core at Engage, New York. So to be fair, I'm going to show you that one as well. And again, with Common Core, it's about conceptual, about understanding where these numbers come from and building that understanding. So what they do there, at this point in the year, kids have probably learned how to find the area of any right triangle. And the way they do that is they know if they can find out what a whole rectangle is, they can cut it in half. So let's just pretend like if this was just 8 and 4, my whole area of this entire rectangle would be 32, but I only want half of it. That's why we divided by 2 to get 16. So in this case, at this point in the year, they've probably learned that. So what Common Core and Engage will probably do is tell you, how can we turn this whole thing into a right triangle? So you're almost imagining a full length. So this whole bottom part, this whole base is 12. And we have our height is 8. So we have it here. And so I can multiply that part 12 times 8. And I'm going to divide it by 2. So I have 96 divided by 2. And my whole piece would be 48. But the tricky part is I really only want this piece. So this whole thing is 48, but I only want this piece. So I need to take out this piece. Okay, so we're going to find the area of this little triangle and we're going to subtract it. We're going to take the whole thing take away the piece we don't want, so we're left with this one. So again, this is what I see in Engage New York. I would do the quicker algorithm way, but I want to be fair so you can see where the understanding comes in. 8 times 3 divided by 2. 8 times 3 is 24. 24 divided by 2 is 12. So imagine if this whole thing is 48, with an area of 48, what if I take away 12 from it? So 48 minus 12 is going to give us our 36. Okay, so that's just another way of doing the same type of problem. Like I said, I like the algorithm base times height divided by 2. Now, I'm going to do one more, and this time we're going to make it a little visually tricky because, again, geometry is very visual. And what if my triangle looks like this? And I have 5 3/4 because 6th graders will get fractional edges. 1 1/2, and this side here is just going to be a 7. Okay, so again, all I need is area equals base times height and divided by 2. Problem is that just looking at the bottom here, this little point, doesn't seem like there's a base. So in your mind, you almost have to rotate it and imagine how could this be flat? And in your head, you're almost going to turn this around, and you can see that this could be a base. I could turn my triangle and put this on the bottom, the 5 3/4. So that's kind of what your brain has to do. In your mind, you have to imagine it, that this is your base. And so how do I find my height? Again, you're imagining this is the edge, this is the base, and I want to get to the highest point here, so I really want this number, because you can see this is where that 90-degree angle is. So I'm going to use 1/2. And this number, that side, you don't need it at all. So numbers are a little bit uglier, but that's okay. We can still solve this. So we're going to sub 5 3/4 times 1 1/2, and we're going to divide it by 2. A little bit more math, but we can still do the same thing. We just have to change these into improper fractions. So 5 times 4 plus 3, that's 23/4, times 2 times 1 is 2, plus 1 is 3, 3/2, all over 2. I can multiply these just straight across. Luckily, we can do that with multiplying. 8. 3 times 3 is 9. 3 times 2 is 6. So I have 69/8, and I'm going to simplify this. Now it's very complex. How many times can 8 go into 63? Well, I know 8 times 8 is 64. And I have 5/8 left over. Okay, so now I'm left with, sorry, I have to use the room here. 8 5/8 divided by 2. Still looks pretty ugly in this form. So what we can do in this case, actually, I'm going to go back to this improper fraction. 69/8, and instead I'm going to use this to divide it by 2/1. I'm going to still divide it by 2. It just looked easier to use than this mixed number. And again, what do? We multiply by reciprocal. (69/16), and so we're getting half of it. How many 16s can go into 69? So I will be honest that in this grade you actually can use calculators, but I'm going to do this in my head. I think 16 times 4. Actually, I'm going to go and check it just to make sure. 16 times 4. Yep. 16 goes into 69 4 times. That's 64, and my remainder is 5 out of 16. So that is my area, and this is square units. Ugly numbers, quite a lot of work, but we're still using it in the same way. You just have to multiply my base times my height. this type of problem, if you're getting it in 6th grade, you will definitely use a calculator for it. Most teachers will recognize that it's just very complex, and I use the ugly numbers in this case. But the format still works altogether. Okay. I actually like these problems. I know they're really tricky because they're very long. There are lots of steps. So I wouldn't be surprised if kids need more support, because if you make any one mistake in any calculation, it affects the rest of the problem. And that can be really frustrating because kids can get the idea, but if they make any error anywhere and they're not sure where it is, it continues on in the problem. They end up with an incorrect answer, and it's so frustrating after so much work. So I understand that, and that's why a lot of times with this problem, I use a calculator just to make sure of my work. And most teachers will allow kids to do that. Okay. All right, so now we're up to our last one for today. Unless anything new has come up in comments, I haven't checked for a second. But this one is now an 8th grade problem. We've had a range today. We've gone from 3rd grade all the way to 8th grade in math. And that's a pretty good range. So in this one, we have another triangle. Don't worry, it's not area. It's a right triangle. This angle is 31 degrees. And this angle here is 3x minus 1. And we want to find out what is this missing angle. So we have to think, what do we know about triangles? With triangles, I know that my interior angles always add up to 180 degrees. So I'm going to just remember that for a second. That means if I add up these three, I should get 180. Okay, so let's do that. We have 90 plus 31 plus 3x minus 1 equals 180. And we're going to start looking for some like terms. This seems very complicated. We want to simplify it some. Oopsie, I'll just use this one. All right, things I can put together. I have some whole numbers, so I can combine those terms. I'm going to combine these two first and get 121 plus 3x minus 1 equals 180. And I can do the same thing with these over here, 121 minus 1. So I can put those two terms together, and if I do 121 minus 1, I get 120 plus 3x is 180. Great. This expression here, I can't simplify it anymore. These are not like terms. But I have 180 here, and I can't simplify that. But what I can do is, I can take this and remove it. Remember, our goal is to isolate this x. I want this x by itself. So this term, I'm going to turn into a 0 pair. Now it's a 0 pair, it doesn't exist, and I have to do the same thing to the other side. So I get 60. So 3x is equal to 60. Again, I want to isolate my x, so they're kind of married. It's a coefficient, that means I have 3 x's, so the opposite of my multiplication, I have to divorce them with division. So I'm going to divide by 3, and so this now cancels out. So I have 1x, 3 divided by 3 is 1, so I have 1x is equal to 20. And that sounds great. Most kids think they're done, but it's still not telling me what this angle is over here. So I can plug it in. 3 times 20 minus 1. 60 minus 1 is 59. So this angle measure is 59. And a kid can check it by doing 59 plus 31 plus 90. 9 plus 1. 10. 1 and 9. I like to put numbers together that make sense together. So 10 plus 8 is 180. So it does equal 180 altogether. And now we have our missing angle. So that's the way we would do this type of problem. We would set it up to 180, and then we'd solve for x and plug it right into the top. So we get our angle. Okay, so that's what we have set up for today. I'm just looking at the back of my technician. Do we have other questions or comments coming up for today in the comments parts? And if not, you can definitely, a lot of people, I realized I said 3 o'clock and didn't say what time zone, that this was 3 o'clock Eastern Standard Time. So for those people who are in California or in Minnesota and didn't know what time to go live, my apologies. I'll make sure I always put the time zone in there. But if you have other questions, you can just drop them off in Messenger. I'm happy to see them there. Friends, family, whoever's out there who needs more support. Or you can also email me any questions at sarah@mathmini, that's the long one, lessons.com. And I take more questions there as well. So I hope this was helpful for you. I know this was the first full week of remote learning. Your kids probably have tons of homework problems to do to set up on Google Classroom. If they're really struggling, please just send me some of the questions and I'm happy to help and support. Thank you guys.